Now, in this video, we are going to take up one more problem, the problem number 48. A steel rod of cross-sectional area 1600 mm square and two brass rods of each of cross-sectional area of 1000 mm square together support a load of 50 kilonewton as shown in the figure. So we have the steel rod of cross-sectional area is 1600 mm square. So this is the steel rod which is having 1600 mm square and two brass rod each of cross-section area 1000. So this is the brass rods which is having 1000 mm square. Together supports, that means both brass rod and steel rod is supported by 50 kilonewton, which is as shown in the figure. Find the stresses in the rods. Takes E for steel, which is 2 into 10 to the power of 5 Newton per mm square. E for brass, which is equal to 1 into 10 to the power of 5 Newton per mm square. Also, find the load carried by each bar and shortening the length of each bar. So the length of the brass bar is 200 mm and the length of the steel bar is 300 mm, which is as shown in this figure. Now we go for the calculation. So the data given, which has been already explained, which is area of steel bar is 1600, area of brass bar is 1000 mm square, length of steel bar is 300 mm and the length of brass bar is 200 mm, and the Young's modulus of steel bar is 2 into 10 to the power of 5 Newton per mm square, and the Young's modulus of brass bar is 1 into 10 to the power of 5 Newton per mm square. For static equilibrium, what is the condition? The total load will be equal to load carried by steel bar plus load carried by each of outer brass bar. That is, P will be equal to PS plus PB plus PB. So 2PB plus PS will be equal to P, that is the total load, which is given as 50 kilonewton, which is 50 into 10 to the power of 3. So what is PB? PB is known as sigma B into AB plus sigma S into AS will be equal to 50 into 10 to the power of 3. But here, since we have 2 PB, so you're going to get 2 sigma B into AB. So on simplification, you're going to get it as 20 sigma B plus 16 sigma S is equal to 500. Why? Because you substitute the value of AB as 1000, that is 2 sigma B into 1000 plus sigma S into 1600 will be equal to 50 into 10 to the power of 3. So on simplification, you will going to get it as 20 sigma B plus 16 sigma X will be equal to 500. So as the area of contact between the steel and the brass bar at the top surface is same, so it remains horizontal even after the compression. Therefore, delta LS will be equal to delta LB. So what is delta L? P into L by A into E. So substitute the values, substitute the formula which is PS into LS by AS into ES, which will be equal to PB into LB by AB into EB. So what is PS by AS will be equal to sigma S into LS by ES will be equal to sigma B into LB by EB. So we know the length of the steel bar is 300. We know the Young's modulus, which is 2 into 10 to the power of 5. So LB, which is length of the brass bar, which is 200, and Young's modulus of brass bar as 1 into 10 to the power of 3, 1 into 10 to the power of 5. So what is that? Substitute those values, sigma S into 300 by 2 into 10 to the power of 5, which is equal to sigma B into 200 by 1 into 10 to the power of 5. So on simplification, sigma B will be equal to 0.75 into sigma S. Now you substitute the value of sigma X and sigma B in terms of any one of these values. So we have this equation here, expression, which is sigma B will be equal to 0.75 into sigma S. So 20 into 0.75 into sigma S plus 16 into sigma S will be equal to 500. Therefore, the stress in the steel bar will be equal to 16.129 Newton per mm square. Sigma B, stress induced in the steel bar, and stress induced in the brass bar will be equal to sigma B, which is 0.75 into sigma S, which is 16.129, which will be equal to 12.1 Newton per mm square. So what is the load carried by the steel bar? The load carried by the steel bar will be PS, which is equal to sigma S into AS. You know the value of sigma S is 16.129 multiplied by area of steel bar, which is 6600. You are going to get it as 25,806.4 Newton. So it will be equal to 25.8 kilonewton. Similarly, the load carried by brass bar, which is PB, will be equal to sigma B into AB, which will be equal to 12.1 into 1000, which is 12,100 Newton, which will be equal to 12.1 kilonewton. What is the shortening of the bar? The shortening of the bar delta L will be equal to, either you can take delta LS or delta LB, because as the surface area of contact, the top surface of the steel and brass bar is same. Therefore, PS into LS by AS into ES is equal to sigma S into LS by ES. You know the value of stress, you know the length of the steel bar, you know the Young's modulus of the brass bar, steel bar. Substitute those values. That is 16.129 into 300 by 2 into 10 to the power 5. On simplification, you will going to get the shortening of the bar is 0.024. So why the shortening of the brass bar? Because we are applying the compressive load. So this is how you will be able to find the solution. Thank you.